So this is basically the curl naman. Since meron tayong divergence and gradient kanina, we can now employ yung ating another method, which is the Stokes theorem. So this is the concept of the Stokes theorem. So meron tayong tinatawag na surface, then sabi ko na yung kanina, surface. But then again, if you want to project this or orient this surface sa closed space C, so ito yon. And di ba ito yung concept kanina nung parang Green's theorem natin, na yung 3D plane natin, yung kanilang certain surface, i-project natin siya dun sa 2D plane natin. Ayun, kaya nga di ba, second higher dimension analog of Green's theorem is the Stokes theorem. So technically, if you have this parang 2D ng Green's theorem, lagyan natin ng volume. So technically, nagiging Stokes theorem siya. So technically, it is simply the integral of the oriented surface S and the line integral along a closed space curve. So yun yung ating curve kanina sa Green's theorem. So yun, and then meron tayong normal vector. So pag normal vector, usually perpendicular line doon sa surface natin. With this, if you want to take the contour integral of FDR, that's also the same as taking the curl of F and then multiplying to the normal vector of TS. So technically, the differential form would be written as this one and then FTDS. So ito mas madali to kaysa sa divergence. So we're given with let S be the portion of the paraboloid. So ito yung ating parang sa Green's theorem na ba yun, yung closed surface natin. Okay? And then this Z is the expression of this paraboloid. Now the curve or the solid is bounded by the XY plane. So we need to verify the Stokes theorem for this. We have this given 2zxy squared by evaluating the surface integral and the equivalent line integral. So we'll be utilizing this concept. F dr is actually equal to the surface integral of the integral of the curl F multiplied by the dot product of our normal to the arc length, the change in the arc length. We need to first determine our normal vector in this case, and then find the curl. So again, yung ating normal vector, again, sabi natin, we can determine that by taking yung ating divergence or gradient ng ating original expression. So that's the same thing kanina. So we have 2x I hat plus 2y j hat plus k hat, and then we divide this by yung kanilang absolute values. So we have 4x squared plus 4y squared plus 1, which usually cancels out after the dot product. So ganyan muna yung ating n, and then the next one is, so okay na tayo sa n since meron tayo, and then we need to determine the curl of our f. So ito yung ating f, 2zxy squared. So pag sinabi nating curl, usually this is the determinant of this expression. Di ba meron tayong I, j, k, and we can only curl yung ating mga vector quantities. So we have partial of x, partial y, and then partial z. And then we can write this 2z x and then y squared. So we take the determinant of this expression. So the determinant of this expression is actually the partial derivative of y squared partial y and then I hat. So I'm using the first diagonal here, and then this one, and then the last term. So it's like plus the partial derivative of 2z. So yun 2z, and then with respect to z times j, and then finally k x partial of x. So we have the partial derivative of x with respect to x, okay, and then multiplied by k hat. So we subtract naman yung next natin, which is ito yung tatlong yan. So we have the partial derivative of y, and then that's 2z, and then we multiply yung ating k hat, and then plus x, ito, and then this one. So we have the partial derivative of z, and then x, and then I hat, and then we add yung ating y squared j partial x. So we have the partial derivative of x times y squared and then j hat. So definitely this is our curl. Medyo mahaba-haba lang, just find the determinant. So kung hindi nyo tanda, gusto nyo gumawa ulit kayo ng Saros rule, so replicate nyo lang yung first two columns and then diagonal. Pwede naman din yan. But anyway, since ilang beses natin ito na-discuss, yung ating curl, yung curl, na-discuss na natin ito before at yung ating determinant, so niretso ko na lang. And then we can cancel out things here. So ito, wala na to, as well as this one. And then ito rin, wala rin kasi wala naman tayong x dito sa expression. Ano pa ba? So yun, basically yun, makakancel out. But then this 3 first parang expression will remain. So with this case, we could say that the curl of f would be equal to 2y I hat, and then this one is the partial derivative of 2z would be 2j hat, and then this one is plus ano ba to? The partial derivative of x. Okay, so this is plus 1k, so just k hat. So this is our curl. And sabi dito, after that, you take the integral of the curl f and ds, pero syempre, what would be our limits? So let's just check kung tama yung curl natin. So this is the curl 2y, okay, 2j, and then k. So yun yung curl. And then the limits, of course, so kita naman natin na yung limits kanina natin is itong circle na to, and then going from -2 to +2 kasi we've already used the surface. So from this, we could integrate na. So let's integrate dito na lang siguro. Okay, so sabi natin dito, that is the curl, so surface 1 curl f dot product with the normal vector, and then ds kasi ano lang siya, surface lang. So anyway, this is our expression. So yung limits natin mamaya natin tingnan, pero remember that is just x plus y squared is equal to 4. So definitely kung dx dy lang yan, y squared mo is equal to 4 minus x squared, and then x squared mo would be 4 minus y squared, and then from -2 tayo to +2 lagi. So kasi yun yung sakop ng ating circle eh. So from this, we could just take the dot product of our f and then n. So definitely it's the integral from, let's just use na lang siguro yung ating dx na lang siguro. So if it's dx, then we have x is equal to something, or dy na lang siguro para x muna. So for this, we have dy, so 4 minus x squared negative square root of 4 minus x squared positive. And then from this point, we have the dot product, so 2y times 2x, that is 4xy, and then sabi nga natin, tatanggalin na natin itong expression na to sa dot product, and then plus 2 times 2y, so that is 4y, and then k times k would be +1. So therefore, this is your final expression for curl from the dot product of this curl and then the normal vector, and then lastly the dx, which is actually evaluated from -2 to +2. Okay, so this is your final expression, and then the answer here, so just integrate, simple lang naman yung integration dyan, and so you can see it from here, so 4xy plus 4y plus 1, and then dito is ano bang order, dx, dito dx dy, pero yun nga, syempre kung dx dy, dapat this is 4 minus y squared, and this is 4 minus y squared din. Pero kung dy dx, this should be 4 minus x and then 4 minus x, and then same lang yun, -2 kasi we have the same value here as the circle. Okay, so yun, just substitute, and then you should be getting ano ba to, 4 pi square units. So let's add that, 4 pi square units. So anong pinagkaiba nito kanina sa divergence? So, kung mapansin nyo, medyo pares yung concept natin, no? But the thing here is that hindi natin hinanap yung curl doon. Ang ginawa natin kanina is hinanap natin yung surfaces and then yung normal sa bawat surface, and then we try to subtract. So technically, that's the solid we're trying to subtract from the idea of the divergence as a triple integral. In this case kasi, we're trying to determine yung parang area niya. So pag area lang, that's just the curl of the expression of the vector function, and then just that product it with the normal vector. So technically, kaya to wala ng subtraction kasi yung ating normal vector dun sa circle natin dito sa paraboloid na to is just 0. Kaya wala tayong kailangang i-subtract dito. Pero if ever na meron pa tong certain volume, so technically, or area, most probably we will try to subtract that. And since madali naman to, planar region lang to, so wala tayong problema dun. So that's 4 pi square units. And then we can solve for this using line integral kasi 'di ba kanina, sabi nga natin pa nating i-prove na yung line integral coming from this curl would also employ the same concept. So if we have f dr, that's equal to mdx plus ndy plus p dz. So we could parameterize using polar equation, and this should be the result of the parameterization. So remember, pag meron tayong parameterization dito, ang ginagamit lang natin na parametric equation is yung yung ano natin kanina, yung circle. So asan ba yung ano dito? Ito yung circle natin kanina, that's x squared plus y squared. You could rewrite this as x of t I hat plus y of t and then j hat. And remember, the value of our r is equal to 2. So therefore, we could say that x of t is equal to 2 cosine t, and then yung y of t natin would be equal to t sine of t. Therefore, the parameterization of this case would be this expression, and then the derivative would be this one. And then we can now proceed with the concept of f r prime dt. So just make sure na we use the derivative of the parameterized equation, and then yung ating concept no z is equal to 4 minus x squared minus y squared, which in turn becomes 4 minus 4 cosine squared t minus 4 sine squared t. And from that concept, we have this value of f, that's 2z x y squared. So yung 2z natin, so ano ba yung z natin dito? So we have 4 minus 4, so we multiply this by 2. That's why ito na yung ating naging value, times 8 to. So I, and then meron tayong, I think that's 2x, xj, and then ano ba yung z natin? So 1. So yun na yun, as it is na k. Pero ito, since this is actually 2z, so itong 2z multiply siya dito. That's why ito yun. And then just do the cross product, and then you'll see na the answer here would be 4 pi minus 0, and that's it. We have already obtained the same concept, or the answer. So in differential form, you can have this, the integral of mdx plus ndy plus p dz. But remember, we have to integrate this from 0 to 2 pi. So it's like 2z dx x dy y squared dz. So upon integration, we could get 2xz plus xy, and then plus we have z y squared. But remember, kung gagawin natin siyang in terms of parametric equation, we just have this x of t that is equal to 2 cosine of t, and then we have y of t that is equal to 2 sine of t. We don't have any value or parametric equation for z, so that's 0. That's why this cancels out, and then this one. We're left out ngayon with xy. So basically, if you want to differentiate this xy in terms of 0 to 2 pi, so dapat ipaparameterize muna natin siya bago natin siya i-integrate. So from this, we have 0 to 2 pi, and then we have x dy, which in turn, kung halimbawa gusto nating hanapin to, we have 0 and then 2 pi, and then ano ba yung ating x? So x is 2 cosine of t, and then ano ba yung ating dy? So therefore, from this case, dy would be equal to 2, and then I think that would be cosine of t. So 2 cosine of t ang ating dy dt. So therefore, that would be times 2 cosine of t dt. And therefore, this becomes the integral from 0 to 2 pi, and then 4 cosine squared t dt. And from this, we can just use yung ating identity sa trigo, and then upon integration, we will be getting 4 pi. So that's just how easy it is when we use the differential form. But of course, that's only given when the value of your z is actually equal to 0, or makakancel out siya. Pero syempre, kung hindi naman, and that will be another story. And in this case, so yun, sunod natin sila ang ating ang ating surface. One, using the concept of Stoke's theorem that the curl of f with its normal vector to its surface is actually equal to the line integral using the concept of the dot product of our r of t and then yung ating vector function na f. And it's also the same as finding the integral of our differential equation form in such a way na we'll be using or we'll be transforming them all of them in terms of the parameterized equation in terms of t. So, yun lang naman yung, yung ating parang generalization. Pero, syempre, when it comes to those na hindi talaga kayang i-parameterize or hindi kayang bigyan ng certain differential form, so, hindi siya pwedeng laging applyan nun. Though ito is, generally, pwede naman siyang applyan lagi nun. So, ito, inire-recommend ko to once na kita nyo na pwedeng magkaroon ng cancellation dun sa ating parametric equation. Pero, syempre, would you, do polar parametric equation, so I don't think na you'll be using that. I think you'll be sticking with algebraic expression lang din. So for cases like that, kung gusto niyo is algebraic expression lang lagi, so you might be using this expression, yung curl natin, and then mag-parameterize na lang kayo if you're quite confident with your polar coordinate skill. So yan. And this is the summary of the formulas that we have discussed. Medyo marami-rami to, but the concept is just simple. If you have, this is the fundamental theorem of calculus. So if you have the integral of f of x dx, so that's just the difference between these two parts. So if we're talking about the unahin natin to, theorem of line integrals. So if you have f dr, so that's just the so itong dr na to, ito yung ating derivative ng ating parametric equation. So we have a dot product of that with our function na vector function, and that's the same concept of taking the gradient of a scalar quantity so that it becomes a vector function, and then you multiply this by the derivative of that certain parametric equation that we have, and then you will end up with a scalar function, and then by just simply substituting the values of that in terms of the upper and the lower limits, so that would employ the same result. So that's just the same concept of the fundamental theorem of calculus. Now, when we talk about Green's theorem, so remember, this is like yung parang mga drawing natin na 2D na nag-trace tayo. It could be simply connected or not simply connected, but the concept remains that if you have an expression where it's mdx plus ndy in terms of differential equation, you can just take the difference between these two partial derivatives and then integrate that with respect to the area, and then this is equal if you want to have the vector function with the dot product of the TDS, and TDS is actually the parameterized equation, so that's dr. So that's the same thing as taking the curl of f times k, and usually itong k natin is the expression used when we want to express the normal curve with respect to the surface. That's why, nangyayari yun yung naging Stoke's theorem. The extension of this KDA becomes NDS, and that's just the same as FDR. So basically, itong FDR na to sa line integrals, sa Green's theorem, sa Stoke's theorem, ay pare-pares lang. Okay? And finally, for the divergence theorem, so if we want to determine simply yung ating solid region, knowing na you have a vector function, you just take the dot product of that with the normal, and then just take the divergence of that certain function with respect to the area. And if you want to find the double integral of this vector function with respect to the surface, normal to the surface, then you just take the triple integral of the divergence of this vector function with respect to the volume. So, parang tatlong limits tayo. So, ito lang yung, generally ito lang yung, yung ating pinaka, dito, may mga sunod natin. Actually, ito lang yun. Yan lang yun. Ito. Tsaka yung isang line integral, saan ba yan? Wala na dito yung ating sa arc length. Yung may arc length tayo na ginagamit. So, basically, yun yung ating XYZ given. Wala tayong vectors dito eh. Ang ginamit natin is yung algebraic expression. So, yun na yung ating concept. So, if you have FDR, halimbawa, pinapanap sa inyo sa FDR, actually, you can use this. Ito rin, pati ito. Though ito, it translates na to this one. So, yun, pwede yan lahat gamitin. Basta kung saan kayo comfortable. Again, this curl f dot nds is usually used when you want to perform algebraic expression, but the curl f and then yung saan ba yun? Itong mdx plus ndy plus pdz is usually done when you want to express those in terms of parameterized equation in terms of polar coordinate system. So basically, ganun yung concept. Okay, and I think that's all na for tapos na ating discussion sa integral calculus. Hopefully, natutunan nyo tong last topic kasi this is one of the hardest topic talaga sa buong calculus. Itong vector calculus kasi hindi siya hindi siya na-visualize agad kasi they're on 3D. And syempre, nagmo-move kasi yung ating mga dito yung mga figures natin talaga dyan. Excuse me, may mga arrow dito. But just remember ito lang mga formulas na to yun sa dulo ng module. And you will understand na pare-pares lang pala yung sinosolve namin. Pare-pares lang talaga yan. Mga curl na yan. Tapos yung mga line integral natin maya-maya. So, kaya nagzi-zero lang lagi sagot natin kasi yun at yun lang din naman yung sinosolve natin na problem eh. Kaya expect nyo na ganun yung maging sagot natin. But then again, when you have questions, let me just know. And in our finals, I'll just have multiple choice problem. So, wala na kayong problem solve. May problem solving pero may choices pa rin yung problem solving. So, yun na yung pinaka-bonus ko sa finals. Tapos sabihin naman, may choices nga pero wala naman dun yung sagot. Pero syempre, I'll try to make sure na nandun lahat yung sagot para naman hindi kayo masyado ma-stress. Pero kung talagang hindi nyo mapalabas, di ba nga walang sagot. So, yun na lang muna and I'll see you when I see you. Okay, bye.